So in this video, we're going to solve radical equations. This time, we're going to have two radicals in the same equation that are not the same inside the radical. Okay, so this video is going to be a little bit longer because the process is much longer, but I hope that you will understand what the process is. Okay, so you have this one, square root of 6x plus 6 equals 5 plus radical 21 21 minus 4x. So notice first that we need to find both domains. We need to verify what are my solutions look like. What am I allowed to have? So first, 6x plus 6 has to be greater or equal to 0. So I'm going to call this domain verification. Okay, that's your first step. So 6x plus 6 has to be greater or equal to 0. And this is an and statement. Both have to satisfy at the same time. 21 minus 4x has to be greater or equal to 0. Therefore, 6x must be greater or equal to negative 6. Negative 4x has to be greater or equal to negative 21. Divide by 6. X has to be greater or equal to negative 1. When you divide by a negative, the inequality changes direction. So x is less or equal than negative 21 divided by negative 4. It's just 21 over 4. So if you put that into a intersection, right, that's what and is. You have x is greater or equal to negative 1, but it's also less than or equal than 21 over 4. If you put that in a line graph, it's going to look something like this. Negative 1, 21 over 4. Both of them are bolded because it's equal to. And the intersection, it's what's in the middle. Okay? So for the domain verification, my solution set must be in the interval negative 1, 21 over 4. Now let's start solving. So the first thing is you want one of the radicals. It doesn't matter which one you choose, but it has to be isolated. The other one doesn't have to be isolated. So you have the square root of 6x plus 6 equals 5 plus radical 21 minus 4x. So let's square on both sides. And by squaring on both sides, it's not individually. It's the whole thing, okay? The entire equation on the right side. On the left side, you get rid of the radical. So you have 6x plus 6. On the right side, you have a foiling. So let me put this a little smaller because it's too big. Okay, perfect. So I'm going to rewrite this as it's like multiplying itself. So we can see the FOIL, which is the hardest part of this is the foiling of the right side. In this case, the right side. So 5 times 5 is 25. 5 times radical. Remember, you're not allowed to multiply a radical inside a number inside a radical if it's not a radical itself. So you're left with 5 radical 21 minus 4x. And then these two multiply again, 5 radical 21 minus 4x. Now for last, since both of them are radicals, okay, you're allowed to multiply them. But look how am I going to multiply them. I'm going to multiply inside as 21 minus 4x squared. Okay, and that's going to be crucial. You want it to look like that. 21 minus 4x squared. Why is that? Because you want to get rid of the square root. Okay, now you have 6x plus 6 equals 25. Now these two add together, right? 5 plus 5 is 10 radical 21 minus 4x. And this one becomes plus 21 minus 4x. Okay? Notice that the radical and the square root, the square and the square root cancel out. Now, the next step from here, once you get this step correctly, is to isolate for the other radical. So we can do exactly the same thing. So I'm going to move everything to the left that does not have a radical. So it's going to be 6x plus 6 minus 25 minus 21 plus 4x equals 10 radical 21 minus 4x. Now, add like terms, 6x plus 4x is 10x. 6 minus 21 is, 6 minus 25 is negative 19, right? Yeah. And then negative 19 minus 21 is 40. Okay. Now, what's the next step from here? Well, notice this 10. I want to isolate for the radical, so I have to divide it. Okay. This is where it's going to be confusing for some of you, right? Because remember, the solving is the opposite of PEMDAS. So we need to take care of the multiplication and division first. So 10x divided by 10 is x, and 40 divided by 10 is 4. Okay, don't forget, do not slash, divide both. And you're left with radical 21 minus 4x. Now from here, you will do exactly the same thing you've been doing before. We square. Now x minus 4 times x minus 4. Okay. We FOIL that. And then on the right side, you're left with 21 minus 4x. Here we FOIL, so x times x is x squared. X times negative 4 is negative 4x. Negative 4 times x is negative 4x. Negative 4 times negative 4 is positive 16. Now we solve for 0, so we move it to the left side. 8x plus 16 minus 21 plus 4x equals 0. So you're left with x squared. Negative 8x plus 4x is negative 4x. Positive 16 minus 21. Where's my calculator at? So 16 minus 21. It's negative 5. So you got negative 5 equals 0. Now, we can use the x method here. Yep, it's back. A times c and b. So negative 5 is a times c. B is negative 4. Two factors of negative 5, then when you add them gives you negative 4. Well, negative 5 and positive 1. So this factors into x minus 5 and x plus 1 equals 0. Now we split it into 2. X minus 5 equals 0. X plus 1 equals 0. That means that x equals to 5 or x equals to negative 1. Now, we look at our domain again. We said that the domain was from negative 1 to 21 over 4. Okay. Now, 21 over 4 is 5.25. Okay? Therefore, 5 is part of my solution. And negative 1 is also part of my solution. So my solution set, it's going to be negative 1, comma 5. And that will be your solution. Okay? Now, we do that for all the other problems. Exactly the same process. Yeah. Like I said, this one is going to take a little while because there's 3 problems we're going to do. But, let's be patient. I don't like that color. Okay, so for this one, same thing. We're gonna first we need to find the domain verification. Okay. X minus 3 has to be greater or equal than 0, and x plus 2 must be greater or equal to 0. Therefore, x must be greater or equal than 3, and x has to be greater or equal than negative 2. Now, if these two must satisfy at the same time, well, then what's the domain? What's the intersection of these two? Well, the domain here is x has to be greater or equal than 3, right? The largest number dominates the smallest one, because if I choose a number that is smaller than 3, then it doesn't satisfy this domain. So the domain is going to be from 3 to infinity. Now we solve. So like in the previous example, we solve for one radical. So we isolate either one. I'm going to isolate the first one. So it's going to be 5 minus radical x plus 2. That's the first step. So isolating for the radical. And then we square. Now again, by squaring is multiplying by the same thing. Okay. On the left side, it gets rid of the radical. On the right side, we FOIL. So 5 times 5 is 25. 5 times minus radical is minus 5 radical x plus 2. Minus 5 radical x plus 2. Then negative times negative, it's positive radical. And remember how I write it, x plus 2 squared. Now you have x minus 3. I'm going to speed up the process because you already seen this, how it works. Minus 10 radical x plus 2 plus x plus 2. Now we solve for this radical, so we move everything to the left. So x minus 3 minus 25 minus x minus 2 equals negative 10 radical x plus 2. Now x minus x equals 0, so you're left with negative 3 minus 2 is negative 5. Negative 5 minus 25 is negative 30. And just like the previous example, we divide by negative 10 here. That gives you positive 3 equals radical x plus 2. From here we square on both sides. This is 9 equals x plus 2. We subtract the 2. That equals x. So 9 minus 2 is 7. Now the question is 7 in the domain? Well, yeah, the domain was x greater or equal than 3. Therefore, 7 is in my solution set. Now for the next problem, very similar. Okay. Practice makes, I don't know the expression anymore. Some say practice makes perfect, but I don't think that's true. I think practice makes it much easier. So again, from here, we find the domain verification. Okay, very important. Do not forget that. That's going to be on the test. Do not forget that. Okay, so 4p plus 5 is greater or equal to 0. P plus 5 is greater or equal to 0. Okay, so 4p is greater or equal to negative 5. P is greater or equal to negative 5. We divide by 4 here. So P is greater or equal to negative 5 over 4. And P is greater or equal to negative 5. So domain verification tells me that I have to choose this one. This is the dominant. Believe it or not, negative 5/4 is the bigger number than negative 5. So it's going to be from negative 5 over 4 to infinity. Now we solve for one of the square roots. So 4p plus 5 equals 3 minus radical p plus 5 This is a p. Okay. We square on both sides. So square here. I'm going to rewrite it again. 3 minus radical p plus 5. So the radical cancels with the square. So 4p plus 5. We FOIL. So 3 times 3 is 9. 3 times negative radical is negative 3 radical p plus 5. Negative 3 radical p plus 5. And then positive radical. And remember how I always write it? P plus 5 squared. So you're left with 4p plus 5 on the left. Here's 9 minus 6 radical p plus 5 plus p plus 5. Okay? Move everything to the left that is not a radical. So we have 4p plus 5 minus 9 minus p minus 5 equals negative 6 radical p plus 5. We got 4p minus p, which is 3p. We have 5 minus 5, which is 0, so this is minus 9 equals negative 6 radical p plus 5. Okay, we divide by negative 6 on both. 3 divided by negative 6 is negative 1/2, sorry. And then negative 9 divided by negative 6 is positive 3/2. That's equal to radical p plus 5. Again, from here we squared. Oops. So it's just better to rewrite it. So I'm going to rewrite it here as negative 1/2 p plus 3/2. Okay. Don't be afraid of the fractions. So negative 1/2 p times negative 1/2 p is positive 1/4 p squared. Negative 1/2 p times positive 3/2 is negative 3/4 p. Same thing here. Minus 3/4 p. And then plus 9/4. Okay. Then we equal it to 0. You have 1/4 p squared minus 6/4 p plus 9/4 minus p minus 5 equal to 0. Now, in order to get rid of that fraction, I'm going to multiply each of these numbers by 4 on both sides. Now, 0 times 4 is 0, so I can do that without changing my equation. 1/4 times 4, so let me write that down. Okay, so p squared minus 6p plus 9 minus 4p minus 20 equals 0. Add like terms, p squared minus 6p minus 4p is minus 10p. Plus 9 minus 20 is minus 11. Now we do the x method. So a times c is negative 11, b is negative 10. So 2 factors of negative 11, then when you add them, it gives you negative 10. So negative 11 and 1. So this factors into p minus 11 and p plus 1 equals 0. We split it into 2. Okay. We add the 11, so p is 11, or p is negative 1. Now, is any of those two in my solution set? Well, negative 5 over 4. What is negative 5 over 4? Negative 5 over 4 is negative 1.25. So is negative 1.25 smaller than negative 1? Well, of course it is. Therefore, these two are in my solution. And that's how you will solve that problem. If you like the video, comment on this. Comment on the bottom if you have any questions, or ask me in class. Thank you.